All right, so yeah, today another little tutorial, kind of like Devin ran last week. I've made the sailing knowledge section on our documentation page, and I'll just kind of be giving a quick tour of what's there and talking about some useful sailing knowledge. Okay, so firstly, I want to say two reasons why it's important to kind of understand some of this stuff. Obviously, number one, understanding the problem is the first step in the engineering design process. So, seems pretty obvious you'd want to know a little bit about how a boat works and how to sail. And then the second reason is we spend a lot of time just hanging out. I mean, for me, hanging out in EDC, kind of waiting for stuff to be set up for testing. And if you know the parts of the boat, then you're a little bit more able to help out and just be in the loop and know what's going on. All right, so we'll jump right in and start with the parts of the sailboat. Firstly, has anyone had a chance to read this over already, or no? No, yeah, that's fine. Don't worry about it. I'm just trying to gauge how much I need to go into detail. I think honestly, the best way to learn this is probably to just look at it on your own time, and then you can read everything properly. So I'll try not to take up too much time here. Oh, that's a little sad that the image doesn't quite fit. I even like added extra white space on the sides of the image in the hopes that it would fit, but it didn't.
You could full screen your browser with F11, then you could see more of the
F11.
time.
Okay, that's a bit better. Thank you. Yeah, so this is a quick diagram of a boat. I'm pretty proud of it, but you can make fun of it if you want. I mean, I guess the winches are a bit big. Thank you. Yeah, so first we got the hull. That's this big flotation part of the boat. Actually, I have a slideshow. How do I exit full? Oh, there. Yeah, so this is what it looks like on the real boat. So you can see we got our hull here. That's the big orange thing. And then we've got the two rudders at the back there. And then that's the keel that fits in. And it has this big weight on the end so that when the boat kind of tips over sideways, it lifts the keel up a little bit. And then the weight of the keel tries to pull the boat upright. So yeah, that's how it doesn't just flip over when the wind blows in the sail. And here you can see there's another picture where the keel's taken out. So it has this little cart that it can roll around on. And yeah, it's pretty big. There's David for scale. So yeah, and then it fits into, I don't know if you can really see it, but there's like a slot in the bottom of the boat and it fits in there. Bow, stern, starboard, port, those are just like different regions on the boat. So the bow is the front, the stern is the back, and then starboard and port are left and right. And then the trick to remember them is starboard and right, the words both have more letters. And then port and left, the words both have 4 letters. So next we have the jib. That's just the smaller sail in front. So here we have the jib in front, and then attached to the jib, there's a jib sheet. So a sheet is just any rope that pulls a sail into the boat and keeps it tight. And then the jib winch is like the actuator that actually pulls on the jib sheet to tighten the sail. And then the jib halyard is just the rope that you use to hoist the jib, meaning to pull it up. So I don't know if you can really see. There's like one of the ropes there. One of them is just goes all the way down, but there's another one that attaches to the top of the jib, and that would be the jib halyard. So it's in there somewhere, but it's a little small and hard to see. So then we'll talk about the mast. So the mast is just what holds up the sails. It's this big long pole. And then at the top of the mast, we have the AIS antenna, which is the longer stick. And then there's a wind sensor there too. So the wind sensor, it's kind of like a pole with like a little disc thingy on top. And then the mast is held up by a couple cables. So there's the forestay in front, and then there's 2 shrouds that kind of, I don't know how well yeah, there's just a lot of ropes in the background with all the masts. But the forestay is this one, and these two ropes, and then that gives the mast stability and holds it up. Then the mainsail, it's like the jib but bigger. So yeah, that's this big sail at the back. It also has a halyard to hoist it up, and it also has a the main sheet which pulls it into the boat, and then the main sheet is pulled on by the jib winch, or the main winch, I mean, which is the actuator. One difference is the mainsail has a boom here, and that's that pole that holds the corner of the sail out. And yeah, that's about it for parts of the boat. Are there any questions about that, or it's all good? Yeah, I should probably mention there are a lot of terms, and it's a lot to try to remember all at once. I have bolded, I explained in the overview here, I bolded and italicized the most important terms. Then there's some other ones that are italicized. Those would be the ones to like focus on and learn first. But even so, there's a lot. So yeah, feel free to read it on your own time. So next we'll talk about some types of turn. So this is something that I hear a lot of people, even like multi-year members on Sailboat, don't seem to understand super well. They'll just refer to any turn as attack, that is not correct. Don't do that. Attack is only one type of turn, and I'll talk about 4. And really, every turn you could possibly do in sailing would fit into one of these 4 types of turns. So basically, we refer to turns based on, there's 2 criteria. One is, does the sail switch sides or not? And then the other one is kind of, are you going, well, no, I'll just jump into it. Maybe I should make a flow chart to explain how you classify turns. So the first turn is heading up. So a head up, or yeah, a turn when you head up, that just means that your boat is pointing higher up towards where the wind is coming from. And it also means the sail stays on the same side of the boat. So if your sail switches sides, it's not heading up. Then the opposite of heading up is bearing off. So you just turn further away from the wind, and the sail again stays on the same side of the boat. By same side, I mean like either port or starboard side of the boat. The sail's the red thing, yeah. I think I explained that, but in here, yeah, it's a hull as seen from above with the sail in red. But yes, I did not say that with my voice, so thank you. And yeah, then bearing off, and then tacking. So attack is when you do a turn that makes the sail switch sides, and the bow of the boat is closer to where the wind's coming from. Oh, I should also mention the wind, it's coming from the top of the screen and blowing down in all of these diagrams. So that means the bow of the boat is closer to where the wind's coming from. So I'll touch on this a bit more later, but you can't point your boat straight into the wind and expect to sail that direction. So there's kind of a minimum size of turn that you have to do your tack all at once while you have momentum to carry through. Because if you try to like tack slowly, you're just going to get stuck pointing straight into the wind, and you won't be able to go forward. So yeah, it's important to carry your momentum through your tack and tack all at once. And then the opposite of attack is called a jibe. So that's when the sail changes sides, but the back of the stern of the boat is closest to where the wind's coming from. Now jibes are pretty different from tacks because your boat is getting propelled through the whole turn. But also, I don't know, it's good to do them kind of, in Sailboat, we like to jibe somewhat decisively too, because you want to be in control of when the sail switches sides, long story short. And then you can do combinations of turns at once. So this is really, it's 2 turns back to back. And I'm wondering, does anyone want to take a guess at what types of turns these are? I totally didn't show the answer on screen. So there's, which type of turn is?
Oh, I think it's bearing off and a jibe.
Very good, Devin. Well done. So yeah, as we can see in this first turn, the sail is on the port side of the boat, because left and port both have 4 letters. And then after the first part of the turn, the sail is still on the port side of the boat. And then, so that means it can't have been a tack or a jibe this first turn. And we see that the boat is pointing further downwind. So that means it's bearing off the first turn. And then the second turn, we see the sail switches from the port to the starboard side of the boat. So that means it must be either a tack or a jibe, but because the back of the boat is pointing closest to where the wind's coming from, this means this second turn was a jibe. Does that kind of make sense? Sort of? Cool.
It's just based on which side of the boat it's going up on.
Yeah, so I should probably make a flow chart to explain a bit better. I think I would say first, you ask, is the sail switching sides, yes or no? If yes, it switches sides, then you're looking at tacks and jibes. If it doesn't switch sides, you're looking at heading up and bearing off. And then either of those branches, they have their own test. So if you're trying to decide between tack and jibe, the question is the bow closest to where the wind is coming from, or is the stern? And that determines between tack and jibe. And then heading up and bearing off, it's, are you steering closer to the wind or further away from the wind? Yeah, again, it'll probably make a bit more sense when you have a chance to read this over. So next we can move on to points of sail. So this is basically just in sailing, you can sail on different angles relative to the wind. And we give names to some of those angles just to know what we're talking about. Most of them aren't really important for us to know. So again, the bold and italicized ones I think are more important. And these ones, I threw them in, but you don't really need to know them. For Sailboat, at least. For sailing, you should probably know them all. So again, just to touch on the no-go zone / irons. So that's when you're pointing straight into the wind. And what's going to happen is your sail just flaps in the middle of the boat and you don't get any propulsion. So you want to avoid being in the no-go zone. Shocker. And then right on the edge of the irons, we have close hauled. So that's when your sail's pulled all the way in and you're kind of trying to make progress upwind. And then there's more names, but the pattern to notice is as we point further and further downwind, the sail is getting let further and further out until on a run, the sail's all the way out. Oh, by the way, it only kind of goes out to 90 degrees. You wouldn't really want your sail to go past that. And it would be, I'm not going to bother explaining why, but you don't want your sail to go past 90 degrees. And then the run here, it's a little bit special because the sail can be on either side of the boat. And you can sail in the same direction. Whereas all these other ones, if your sail's on one side, you have to sail in one direction. And if your sail's on the other, you have to sail in the other direction. So then upwind sailing, that's basically we're just tacking back and forth to make progress upwind. So if we're trying to sail towards this lighthouse, then we're just going to be on close hauled with the sail all the way in and tack back and forth. And then downwind sailing, and so in Sailboat, we try to avoid sailing straight downwind. So we also like to jibe back and forth so that we don't have to sail straight downwind. Yeah, that's about that for that page. Are there any questions? Some of this stuff I'm kind of just saying and not really explaining. Is there anything you guys want me to explain better? It's all right. Cool. And then there's some miscellaneous information. So heading and bearing, they have different meanings in real navigation compared to in Sailboat. I'm going to skip what they mean in real navigation because that's not really important right now.
Well, I think for the new project, I think we should stick to the actual definitions.
Oh, so, okay.
Yeah, maybe we don't have to explain the Ray definitions. We definitely want to stick more to the sailing term so it's easier to understand.
Okay, yeah, that makes sense. So should I explain the real definitions then, or?
Yeah, that would be good.
Okay, sure. So the probably the most important one is heading. So that's just which direction is the boat pointing in. And you can measure that relative to true north, or you can measure it relative to compass north. I don't think we have a compass on Ray though, right? So then our headings would be relative to true north. The reason for the difference is the magnetic North Pole isn't perfectly aligned with the geographic North Pole. So there's a little bit of a difference, but it's the same idea. So you're heading here, this boat is the heading is here in H. So that's just the angle measured clockwise from true north that it's pointing towards. And then in real navigation, bearing is not something that one object has, but it's how you describe a second object in relation to a first object. So the lighthouse has a bearing from the boat. And then there's two ways of measuring that. You can measure it relative to true north, or you can measure relative to the direction the boat is facing in. And yeah, I labeled them all in the group diagram. Does that kind of make sense? I feel, Patrick, I feel like I should explain what they mean in Sailboat too. Or are you guys not
Actually,
working on Ray?
It's probably mentioned here in the text, but I do have a question about the bearing. Say if like the boat was pointing southeast, right? Would the bearing be like what's closest to the lighthouse, or would it go clockwise all the way around?
That could depend on your angle measuring convention, but probably it would be the large angle. So if the boat's pointing southeast, that would be like this way. So yeah, I think the bearing would be like 200 or like 300 degrees or something like that. Would be the normal way of measuring it. You could also say it's like negative 30 degrees or something if you wanted, but yeah,
Yeah, that's the equivalent. Yeah, okay.
Yeah, so
Yeah,
I think
it's the same thing. So
yeah, I think the normal convention is you bound the bearings in 0 to 360, but like either would mean the same thing. So yeah.
okay, thanks.
Track made good. I think this is more important for pathfinding specifically. The key idea is the heading is not, so the heading is the direction the boat's pointing in, which is not necessarily the same thing as the direction the boat travels compared to like the seafloor, for example. So if there's current and obviously the boat's going to get blown a little bit downwind, then that kind of, so if it just went in the direction of its heading, it would end up here somewhere, but because of the current and stuff, it'll end up down here. So it's a good idea for us to keep track of the difference. And Patrick recently made a big effort for us to use track made good instead of just heading. I'm just going to say it quickly. In Ray, heading and bearing, really they both mean heading. They're just different conventions of measuring the angle. And I'm deliberately not going to say what the conventions are because I don't want to get it wrong. So just look at the applicable code to figure out what the convention is. I wouldn't even be confident that we have consistent definitions for bearing and heading.
And I think this only really matters for pathfinding.
Okay, yeah. Oh, this is an important concept. So yeah, basically, I'm just gonna jump right in. Basically, there's a couple different types of wind that we can talk about. So true wind, which is just if you're standing on the ground, not moving, you feel the true wind. If you're on a moving thing, then you'll feel the apparent wind, which is different. And if you're standing on a moving thing and there's no true wind, then you just feel the boat wind. So that the boat wind is always just the speed of the boat and blowing straight towards whichever way the boat's going. And then the apparent wind, it ends up being a vector sum of the boat wind and the true wind. So I put how I did my calculations there. You can figure out the formulas if you need to. Should I explain that more, or is that kind of makes sense? A little bit? Okay. So again, I'm circling back to tack because it actually has a bunch, there's 3 distinct meanings for tack in sailing, which is kind of annoying of them. They could have come up with different words. The first one is the type of turn that we covered before. The other one that might be good for Gus to know is starboard tack versus port tack, which basically just like the simplest way of understanding it is just whichever side of the boat the wind is hitting first. The most technically correct is it's the opposite side to wherever the sail is. So these boats, the sail is on the port side of the boat, so they're on starboard tack. And then these boats, the sail is on the starboard side of the boat, so they're on port tack. And then if you're sailing straight downwind, the tack, again, it just depends which side of the boat the sail is on. So here the sail is on the starboard side, so the boat is on port tack. And yeah, that's it. I have nothing further to talk about. Are there any questions? Yeah, it's all good.
I think one thing it might be, I just realized it might be good to just go over for a second is the sort of difference in ways people talk about and think about wind conventions, because people oftentimes to mix up like the idea of, if you say that what direction the wind is coming from, but also like the wind as a vector, right?
That might be in the text somewhere. I wrote it a while ago, but it probably should be in the text if it isn't. So I'll check for that later. But yeah, in just conventional life, I find a lot of people ask like which way is the wind blowing, and then they point to the downwind direction. In sailing, for some reason, it's easier to just talk about where the wind is coming from. So you point in the upwind direction if someone asks. Whereas, yeah. I'm not sure if we follow that completely in our code, but in the new project, probably it's better to talk about where the wind's coming from.
Yeah, I think
Does that address what you wanted to say, Joel?
Yeah, but then also like if you're doing the math for apparent wind, then it's better to talk about where it's going, because that's like the actual sort of vector velocity of the wind.
Yeah, that's also true. Where'd that go? Yeah, so obviously the arrows I drew here is the direction in which air particles are moving. So yeah, there's a bit of a difference there.
I feel like that would only, oh, sorry, Patrick, you can go.
Okay, so a lot of the confusing conventions that came from Ray is because of like the sailing conventions versus the mathematical conventions, and we're trying to like do both of that. For example, in math, usually 0 degrees is to the right.
Yeah,
and in sailing 0 degrees would be like forwards.
I think I addressed that in the sailing or the ray heading and bearing. But yeah, basically in math, the common way to do things is 0 degrees is like along the x-axis. Yeah, 0 degrees is like along the x-axis, and then positive angles go up from there. In sailing, the more common way to do things is 0 degrees is north, and then angles go clockwise from there. And we use both conventions a little bit, and that's kind of confusing and not ideal. I think at least in pathfinding, I think the better way to do things would just be stick to the sailing convention where 0 degrees is north and then we go clockwise. Yeah.
Also, sometimes we bound it from 0 to 360, and sometimes we bound heading from -180 to 180.
Sometimes we even bound it from like 90 degrees to -270 degrees or something like that. I don't know why. Or I might have fixed that for controls. I can't remember anymore. But yeah, there's some weird angle conventions out there, and probably the better way to do it in the future is stick to 0 degrees is north and then count clockwise.
Yeah, this is definitely something that we need to like have further discussion on for the new project, because we want to simplify things as much as possible. Like Ray wasn't originally intended to be confusing, but that just arose from the different conventions of like different libraries that we use. So we need to make like some clean like conversion codes, like abstract that functionality away from like our actual like functional code base.
Yeah. Is there anything else people want to talk about, or should we move on to sub-team meetings? No? Okay, I think we'll move on to sub-team meetings then. So I think I'll end this meeting, and then we'll all jump into our sub-team meeting rooms.